All right, this is a quick video for the Pre-3.1 Activity. Once again, this is, well, obviously by the title, you should know, I guess. Pre-3.1 Activity. Just a quick little warm-up type thing to kind of get you in the right frame of mind for section 3.1. Let's run through this really quick. So consider this equation. 3x plus 2y equals 18. Are you able to solve it? Can you solve this equation? And, I mean, what do you notice about this equation that is probably totally new to us as far as, what we've done in this Integrated 1 class so far? What's the new twist, I suppose, in this equation? And are you able to solve this? And maybe by now you might have decided, no, and let me elaborate on that. At least not in the way we've been solving equations lately. So we're not going to be able to solve this equation the way we've been doing equations in like Chapter 2 and so far in Chapter 3, and so why not, right? Why not? Why are we not able to solve it? And again, like maybe you've already realized the reason or noticed that there are two different variables in this equation. We have an x variable and we have a y variable, two totally different variables, which that's basically the reason that we're not really able to solve this the way we want to or the way we've been doing. What if I told you, moving on pretty quick here, if I told you that y actually equaled 6, could you solve the equation now? Like what if you just knew that, oh, that's not really y, that's actually 6? I mean, now the answer is obviously yes, right? Because if you actually let y just be switched out with 6 or substituted a 6 in for the y or replaced it because, y literally equals 6, now you have this. 3x plus basically 12, equals 18. And now it immediately becomes an equation that we've solved like dozens of times, even just so far this semester together, you and I. So I just kind of left here, dot, 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 because what would you do next? You would then just subtract 12 from both sides to start getting x by itself, and then you would divide both sides by 3 to finish solving for x. What if I told you that y equaled -2 instead? Excuse me. Could you solve the equation? And long story short, yeah, I mean, this is basically the same idea as what we just did with y equals 6. If you knew that y equaled 2, same thing, like if you actually just kind of replaced or subbed in -2 in for the y, that would get you this right away, which is now totally solvable because this becomes, what is 2 times -2? Well, that's -4. And so all of a sudden the equation looks like this, which, okay, now it's really just an x variable, just like up here. All we really have now is an x variable, and as long as the equation only has one variable in it, you can totally solve for that. And again, dot, 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 because I don't think we need to reteach you thoroughly, slowly, step by step, what we do and why we do it. You know that we're going to add 4 to both sides and then divide both sides by 3 to finish solving the equation, at least for x. Ooh, little technical lingo there, like watching my words all of a sudden very carefully. The original thing, like, could you solve the equation? Yeah, like, so far as we can tell, as far as what we're thinking, if we know that y equals 6 or y equals -2, we can at least solve the equation for x with, because x would now be the only actual variable. Final phase here of the warm-up activity. What if I told you that, drum roll please. All right, enough of that. What if I told you that y equals x plus 4? That's interesting, or that's different. Instead of saying, oh, y equals 7, or y equals negative 12. What if I told you that? Like, okay, that's what y equals. Could you do the same thing, basically, we did on these first couple? If y actually equals x plus 4, couldn't we replace the y with that? And if we just replaced or switched out this y variable with x plus 4, would that make it solvable? I mean, would that be almost as good as just replacing y with like a 7 or a negative 2? You know what I mean? Let's see. So if we actually just now say, well, if y literally equals x plus 4, let's totally replace the y with what it equals. So now all of a sudden we have this. And yes, it was vital and necessary, and any other synonym. It was important. There you go. Another one. It was important to put parentheses around the x plus 4 because, we're multiplying y by 2. And all of this equals y, not just the x. The entire x plus 4, is y. So we have to make sure we're multiplying the entire x plus 4 by 2, which means we need to include parentheses. Anyway, getting back on track. Now that we have this equation, is this now solvable? Can we solve this for x? And you should know almost right away, the answer is yes. We only, even though the variable appears twice, there's an x right there and an x right there, it's not like it's two different variables, okay? It only technically has one variable, x, and we can totally solve for x right now, okay? So what would we do first to start now actually solving for x? Well, we would distribute the 2, first of all. We want to clear parentheses. And so when we multiply 2 to the x, we get 2x. And then when we also multiply 2 to the positive 4, we get positive 8. So that is the next step, naturally. And then we just, again, we're just solving now, We're now we're now actively solving for x, what would be the next step? Wouldn't the next step be to combine those like terms that are already together on the left side? So that'd be 5x, plus 8 equals 18. And again, just like before, dot, dot, dot. Because we would just keep this going, like subtract 8 from both sides now, and then divide both sides by 5. But the bottom line is, quick recap, when an equation has two different variables, it's not really solvable the way we understand, solving equations up to this point. We can't really solve an equation like this the way we've been solving because of its two different variables. But if you happen to be able to plug in a specific number for one of the variables, it becomes solvable for the other one. Even if what you're plugging in is something not exactly super final, even if you're just plugging in x plus 4 in for your y variable, it does then all of a sudden become solvable. And that does it for the warm-up activity.